Hey guys, this is Hetu and welcome back to etlqalabs. Hope you all are doing good. And in this video, we will talk about indexes in database, right? So these indexes are very common. It is not specifically applicable to any particular database. Rather, it is actually database agnostic topic. So understanding this concept is very important for any person working in the database, whether in any capacity as well, right? Whether you are a developer, tester, architect, or project manager, right? So understanding the database concepts, especially this index concept, is very crucial, and this directly translates to your contribution to the project, right? Once you understand, you will be able to guide your team, and that obviously will be having a good overall contribution will be improved, right? So let's try to understand what is index first of all. So couple of things that we need to understand. What is index? All right. Why do we need it? Why do we need? Second question. Third question is advantage. Of course, there will be some disadvantage as well. All right. So we'll try to understand each of this. Okay. And probably we will see that whether we have the time is allowing, then we will cover the practical aspect of it. Otherwise, we will try to see a follow-up session about it, right? So let's try to understand, guys, quickly. What is index? So first of all, we need to understand before indexes, we need to understand how actually database query works, right? So for example, let's say I'm just going to give you one example. Let's say I have here, this is student table, okay? And this student table is having two columns, let's say, all right, student ID, student ID, and maybe a student name, guys. They are the two columns, all right? Now, let's say I say not A, guys. This should be one, let's say 2, 3, 4, something like that, 1000 or 10,000, 1 lakhs, let's say, and this is 10. All right, something like that. So it's not that your student ID column will have all the sorted data, right? So it again depends. Like it is not at all sorted, right? And then name will be like this: A, B, C, whatever, guys. You just fill. I mean, just understand that, right? These are the two columns, and we have the data. And assume that this is basically containing. So the overall data that we have in this particular table is maybe it's a kind of 1 billion record. Okay. Okay, fine. 1 billion record is there in this particular student table, and which is kind of maybe 50 MB. All right. 50 MB of size it is actually taking. The database size is of 50 MB, and this particular 1 billion row is actually spread across this particular 50 MB. Okay, this is the size of the whole database, and we have only single table. Just assume it, right? This is just a hypothetical scenario, guys, right? Now, what will happen is when I run a particular query on my database, which is not having index. So this is basically I'm talking about having without index, guys. Okay, so without index, all right. So when without index, when I'm saying select star from student, student, where student ID, student ID equal to 10,000, something like this, right? So in this case, guys, student ID equal to 10,000, my SQL engine or the Oracle, I mean database engine, to be honest, you can just say that database engine doesn't know how do I get this particular and where it is basically this particular student ID is there in this particular table. So it can be the first row or it can be the last row or it can be anywhere because the data is not sorted here, right? So what will happen here is basically it will the Oracle or the database engine will actually when the moment I fire this query, it will start scanning this particular table. It will actually go one row by one row, second row, third row, fourth row, until this finds it true. It will actually keep searching, right? And if it doesn't find, it will go up to last row as well. If it is fine, then it will return. If it doesn't find, then nothing will return, right? So in this case, you see that this is actually 1 billion record. Literally, it has to scan through all these 1 billion rows in the worst case scenario, and in the best case scenario, maybe it is finding the first row itself, right? But we always consider about the worst case scenario. So in this case, it might take, let's say, 30 minutes time. Okay, I'm just giving you some example, which is not at all acceptable, right? This 30 minutes is a huge time. Nobody in the world is going to wait for you to give the data in 30 minutes time for a single query like this, right? So this is of no use, right? So this solution itself is of no use, right? So you see how the performance is actually is a crucial parameter or crucial factor for any application, right? Specifically, when we have the huge amount of data, like a data warehousing solutions, where we have the trillions and billions of rows, right? In that case, the using the indexes is very important. Why? Because indexes are the one which will actually help you improve the performance. We will see how it is, but you now understand this is also called, guys, table scan. Okay, this does a table scan. Table scan means it will actually scan one by one. All the rows it will scan until it finds, right? So this is not efficient at all, right? So what we have to do now, there are, okay, so before that, what we will try to understand is, we will try to understand two type of applications, guys, okay? So there are write intensive applications and then read intensive, guys, okay? Just see this, read intensive apps or applications, okay? So guys, there are the four basic operations that you might be knowing already, right? So C R U N D, CRUD operation, right? This is called create, this is read, this is update, right? And this is delete. Okay, so these are the four basic database operation that is something that we have to perform on very basic level on day-to-day basis. Now CUD, these are basically which are actually changing the data, which means writing something on the database or the table. These are called CUD. These are um, these are called CUD, which are the write intensive operation, and only R, which is read operation, is only read intensive. This is used for read intensive. One second, guys. I'll just expand it a bit here. Fine, fine. Now see, two kind of application, right? Now, when I talk about the ETL and data warehousing and all those kind of operation, so example of this kind of application is what you guys, guys, this is kind of data warehousing application. Why? Because we are actually majority of the time we are reading the data from the data warehouse, and which is actually used for our analysis and report generation and all those purpose, right? That's the reason this data warehousing, ETL, all these applications are read intensive applications, are read intensive systems. Rather, I would say system. Maybe you can say system. It is much better word. Okay. So this can also be a system. All right. So this is what actually we can. Yes, guys. So, and when I talk about the write intensive operation, write intensive operations can be operational systems, like you can say the bank's typical banking system, maybe, right? So the banking systems are basically the write operations, right? Fine. Now, what we have to do is just to give me a second, guys. right, fine. Okay, yes. So CUD and which are write intensive operation and read intensive operation. So they are the two different kind of operation. What we do is basically we use indexes mostly. Use of indexes are happening here. Index use here. Yes, but less here more. Okay. All right, guys. But it's not like that we don't at all use, okay? We don't at all use, it's not like that. But we are actually, the read intensive systems are more supportive to indexes because we have to actually read where the performance matter to fetch the data like this, right? We can't wait for 30 minutes to get this data. So hence, it is important that we use the indexes. Now, so this is one of the thing that I told you. We rather want to get this data in fraction of second, right? So how do we use it? We have to use the indexes. That is the whole purpose about it, right? Now, what exactly are indexes? Now we will try to understand. Okay. So what are indexes, guys? First, indexes are basically, I'll tell you. Index definition are basically these are the database objects. Okay, database objects which helps fetch the records in faster manner. How it does and all those things we will look at later, right? So these are nothing but these are the database objects like a table, views, and stored procedure, anything else. These are the actually objects which are actually created in the table. And what are those index? How do we create the indexes and all those things? We will see it right now. Okay. Now, for understanding this, okay, indexes we know now, we have to use the indexes to improve the performance. But in this table, how do we actually indexes work, right? So when I say here, indexes, how the indexes work, guys, okay, so let's try to, so in the previous example, let's say I said that 50 MB data, 50 MB is there, the student table is worth 50 MB, okay. Now let's say here I will put it. Now we have, let's say here, student ID, and then here no, I think I have used std ID. This is the one, and then here I use block. So now in memory, this 50 MB table memory, in memory secondary hard disk where the database are getting stored, right? It is basically stored in blocks, right? So let's say block one, block block one. Oops, one second. Block one. Like that, guys. We have all these blocks where the data is stored. Okay. Two. We don't have any single block. Okay. So in the entire database is actually scattered through blocks, multiple blocks, right? So let's say here for simplicity, each block is made of 10 MB. Okay. Makes sense? Because total database size is 50 MB. Okay. Each block of this database is actually, okay, one second. Okay. This is kind of 10 MB each block. Now, what if I have actually, I can store a student ID, let's say 10, 20, not like this. I can't do it like this. Okay. 10, 20, 30, okay, 40, 50, 10,000, something like this, right? What if I can just store this and it can also be repeated, right, guys? Like this block, maybe multiple ID can be actually in a one block, right? So one block will contain a good amount of, student ID. So what will happen is when actually I go and find out, let's say I want to find out where student ID equal to 10,000, it actually go to this particular block itself. It doesn't need to go to all this block, right? Because this is the mapping, kind of mapping, right? Whether it actually try to search, the query will try to search into this particular block, this particular table, and it finds, oh, I found this particular student ID. It is actually stored in the block 5 in the database. So what will happen is actually our we will actually fetch the entire data from the block 5, bring it into RAM. So how it happens, right? So this is RAM and this is HDD, guys, right? This is disk, secondary disk, right? That's where all the data are stored, right? So now what happens is basically this 5 block will be bring into the RAM. It need to be found this particular 10,000. It is fine, then it will return it. Otherwise, okay, in this case, it knows that exactly I have this particular block. What if we don't have this particular data? It actually will just check whether we have any entry here or not. If there is no entry, it will say there is no data. Okay. So it will not actually start any operation. It will first check whether we have the student ID or not. If it is not, then it will not do. So worst case scenario is that it finds, okay, not worst, but the thing is when it actually doesn't find anything, it will say that okay, I don't have, so it will not scan that table. uh, so this is called the index basically, right? So index, this is called index. This is the concept of index. Okay, index will actually contain one particular ID which is called index column, and then you have the blocks on the database. These are the physical blocks in the database. So it will actually, it is internally. So when you create an index, it will be internally auto allocated, right? So that is how it is very fast, because when you say select star from this, and when you say this is 10,000, in this case, it will actually go to this particular student ID. It will find, then it will fetch the block this, and it will find other record, other information like student name, student grade, etc. Whatever, right? So it will actually go to refer back to the student table, and it will fetch the data for you, because you are actually trying to find select star, isn't it? All the information. Got it? So this is how it is very crucial and very important to use the indexes. Hope it is giving you some idea. In case we don't have index, in that case what will happen, we have this all this block, it will actually this particular mapping is not there, right? So it has all this block, it will actually start from block 1, it will take all the data from block 1, it will try to find it, it doesn't find, second, third, everywhere it will find until it finds here in the fifth block. So what in this case, where we don't have indexes, we have not created indexes, in that case it will actually fetch all the blocks, which means entire 50 MB database has to be scanned through to get this particular record. Get it? But in this case, the advantage is it actually get this particular table prepared. It actually goes and it finds just, okay, where is my 10,000? It will immediately go to this block 5, get the data and get all the details about this particular record, right? So see, this is actually saving a lot of time here, right? That is why the performance is very fast. Okay. Now, second thing is, um, what is okay, so how do we create indexes and all those things? I think we will look into the next session, because this session is getting lengthier, but that will be more of a practical aspect, guys. Okay, but for now you understand that indexes are not always very so we will cover why do we need indexes. We have covered what is index, right? What is index is basically we just understood what is index. Why do we need index? Because we want to improve the query performance, the select performance, right? As I said, that the read intensive system will have lot of performance, enhancement, or lot of performance advantages, right? And whereas there is disadvantages as well. Okay, what are those disadvantages, guys? The disadvantages are that the if there is, let's say, write operation. Okay, so now what is happening in the real time? Okay, let's say I have student table. This particular table is there, guys, right? So for example, this is there. Okay, now what will happen is when I create an index, I have this particular structure created index, and this will have okay, I can actually put it here, something like this. 1 billion rows exactly, right? So here let's say I have some ID. I'll put the ID. I'll put here block actually. So I will actually take, because this is my index column, okay? I actually create an index column on this. Index. Getting? So when I create an index on a student ID, why I'm creating on a student ID? because I have to actually find based on this where clause. In where clause, I have a student ID. That's why I want to find this 10,000 student ID. So where I need to create the index, I have to create index on this particular, because this is the my requirement. I want to find this particular student ID. So I need to have some mapping of the student ID to the block. Then only I'll be able to find it, right? So here it will be block like 1, 2, 3, 4, 5, and literally all these indexes. This will have all the, let's say 10, 20, up to 1 million. How much ever we have the record, right? Everything will be here literally in this particular index. You assume that this is kind of table only again, right? And these are the rows, same rows, because everything we are storing here. Okay. Maybe if we have some duplicate and all, that is different matter. But yes, literally we'll be having 1 million record here, and here will be block 1, block 2, something like this. Okay. So this is something additional overhead for our database. If we are not creating indexes, which means I'll go to all the blocks and find it. In that case, I am not doing anything. It is actually searching on this particular table itself. Okay, 1 million records, wherever it is, 1 billion records. Now, when I created this, this is also taking some additional space or not? Because see, you are creating indexes, which means it is storing student ID in block. Obviously, it is taking lot of time in your lot of space in your database, right? So, two advantages. One is basically database storage will be increased. Second advantage, what if we are actually doing lot of write operation, right? So when, let's say tomorrow I am going to update this with 1001 student ID 1, or maybe let, okay, so student ID 10 was wrong. So let's say I have corrected it to 1001. I mean, just hypothetical scenario. In that case, I also need to make sure my index table, I would say index table, which is not right word, but you assume that this is index, right? So my index is also supposed to have this particular update. Otherwise, next time when I say search 1001, it will actually not found in this index, and it will say that data not found, something like that, right? It will not give you the result. That's the reason index also need to be updated. So in case we have the write intensive operation, we have the overhead of updating the index as well, which is really very difficult, right? Because in banks, for example, people are actually going to do deposits, or people are going to withdraw money or update some information. In that case, if you are putting lot of index, a lot of what you say, indexes on, let's say, customer ID or something like that, all those columns will be there, right, in the bank. In that case, there will be a lot of overhead on the system, because once they update in the actual table, the index will automatically be updated, which means it will take a lot of CPU, it will take a lot of time, space as well, right? So everything. So that's the reason indexes are not always good. Okay, indexes are good only for read intensive operation, such as data warehousing operation, where actually we are generating lot of reports throughout the day, but write or the load of the data happens once in a day, right? You got it? But in bank, this is other way around. We actually find, we actually read the data only sometime. Let's say some customer went to the bank and approached the bank and asked them to generate some statement. So in that case only the bank is going to read it, their account detail, and then give the details to them, right? Other than that, bank is more involved throughout the day in write intensive operation, whether it is create, update, or delete, whatever, right? So that is the reason indexes are very good for this. No and yes doesn't mean that it doesn't need to have. There should be some indexes on some of the columns here where you need some kind of updates and all, but then it is more suitable for the read intensive systems, right? So these are the basic thing about these indexes, and I'm sure that you understand, you got some idea. But in the next session, what we will do is we will actually go to SQL developer. We will literally try to create an index. We will see how indexes are there, how it is stored in the your database, and what does it mean, and what everything, all the details we will try to find it there. Okay. So hope this video really makes sense to you. And guys, believe me, I don't compromise on the size of the video. I just don't want to make a video like 10 minutes, 5 minutes, 15 minutes like that. I want to make sure you 100% get it. So once you watch this video, you don't need to scroll through other, videos to get this concept. Okay. So I really make sure that, content of the video, I don't want to compromise. The length of the video can be here and there, but important for you and for me as well is that you understand, you get the core concept about it, right? Rather than scrolling through multiple places and getting yourself confused, right? So this is the basic about the indexes. We have not looked at the practical aspect of it. Maybe in the next session, I'll soon cover all these practical aspects. Okay. All right, guys. Thanks everybody. And yes, until we see next time, I hope that you get this concepts clear, and then see you soon with the next video. Until then, happy learning. God bless you. Bye.